let's look at the steps of building an electrical system model. We have on the screen here a simple system with two loops, and I have outlined in there as a first step we need to recognize the elements that are present. So what are we having here? This is a voltage source, an alternate voltage source, and it has a resistive element over here. Let me just make sure we have it with the correct symbol here. And you have an inductor over here, and then we have a C capacitor here. This symbol and the US symbol means a current source. And then we have this R resistor too. We have a battery which is also a voltage source, and we have another resistor over here. So those are the elements that we have on the system. I think what we need to do is, let me see if I can make this perhaps a little bigger in here, so that we can see good. Maybe up to this one, eh? How is that? I think that's good. So we're going to say recognize the elements present in here. And what should we do as a step number 2? As a step number 2, I would say that we need to use a one junction to represent the distinct currents. Something doesn't like this. Think. How is that? Very good, very good. So let's do that. See, we have two of these. So to build my model over here, I'm going to say, okay, do that. I'm going to use a one junction over here for I1, and another one for I sub 2. Okay. So in here I need to build my model. Just change color maybe. And here the voltage source, this is a source of effort in here with value V of t like this. We have this R element over here with R. And then we have the I over here, but you know, we have basically done step number 2. Step number 3 is going to be step number 3. I would say attach the elements that experience those currents. So the currents that we use in number 2, we need to use for step number 3. So I already started doing this. SE is obviously here, and then the R element is also over here. So there's the R. Then we have the I element up there, the electrical I element with value L. This one is the R element with value R. And in here we have to put this element, which is the voltage source with value voltage of this battery. This is going to be like this. And then you have the R element over here, which is going to have as value R sub 2. And then this is as of a step 3. Attach the element that experiences those currents. Then we need to continue building this. We need another step. I'm going to go step number 4. Is going to be step number 4 is going to be I would say use 0 junctions to represent the current differences. Okay, and then you could say use 1 junctions to represent those differences. Let me see what we're trying to, what are we saying here? Let's just do it. So it's very obvious that the elements in the middle here see the difference between I1 and I sub 2. So we need to use a 0 junction to represent that difference. So this is I sub 2. Let me do it with red over here. So we're going to put the 0 here. And when you do I1 minus I sub 2, this is what will happen. You'll have another one that says I1 minus I sub 2. That's what we're trying to say here. Use a 0 junction to represent the current differences. That's this one. Use a 1 junction to represent those differences. So the difference is really I1 minus I sub 2. We're doing this deliberately because we're setting up for the next step, for step number 5. Step number 5 would be to attach the elements that experience the current differences. Okay, so there you go. Here we have in here a couple of options. One, we correct the R, and then we're done. So you see the experience the current differences is obviously the C element over here with value of C, yeah, and you have this current source too because that is in here. Now this is interesting because it says that the current should be the same, the current differences between these two, but it turns out that this thing is adding to the current. So that is a dilemma in here, how to represent this, because besides the current differences we have a source, and you know that this this element is a source that it would have to go in here with, no, excuse me, this is a current source that we need to add. So in this particular case, no, let's just correct, this is a source of flow. And then we're going to go over here. Yeah, this would be the bond graph model based on what I have done. There's a final step, which would be I would say check the power flow and you say incomplete. I would say this last step is optional if using CAMG. Okay, so let's just correct this one. It says optional. So this is where we are. Hmm? Oh, R sub 3 also we are basically ignoring over here. So thank you for that. We need another one over here, which is R with value R sub 3. What we need to do in this case is that, okay, so we have the power flow like this. But the causal marks, we haven't done this. So the causal marks, we have the source of effort in here, and then we put the I in integral form like that, which makes this to be like this, yeah. And then we have a source of effort here, which is like this. That doesn't make much progress in there. This is the source of flow. Based on this, what we're saying is that this current will be determining what this is going to be. So in here, the source of flow will do this, and then this will have to be like this, which means that the C is in derivative form. Oh, hold on for a second. I actually made a couple of major mistakes right now. We need to put this. If this is like that, then this other one is like this. So it's normal. They were integral form here. And then we have the source of, we have the two flows in here, then this has to be like this. And once it's like this, then it makes the others like that. And that would complete the causal marks and the bond graph and the power flow as well. Okay, we are basically finished this example, but I think we need to make a couple of observations that I find unique to this example. I would like you to examine this situation here that we have the way we define them like this, the sense, a positive sense would be this, yeah. So if there is this coming this way on this branch, and if I2 is redefined this way, the difference would be a current flowing downwards here. You know, the difference I1 minus I2, which is what this does. This particular system puts throws a monkey wrench into it, because this is a current source. So it actually doesn't matter what the difference between these two is. This is going to determine what the current is for over here. And that's what the capacitor is going to see. So normally, if this system, this source would not be here, this would be the current that we see, the difference between these two. But in reality, because of this source, we see that this one is determined by the current here. So I just wanted to make that observation that the one here, although it should be I1 minus I2, from practical purposes is eliminated by the fact that this guy controls what the current should be in there. And you know, I'll just maybe circle that so that you can see what my concern is, okay? So in reality, this is not the current over here because of this one. The second observation that we have in here is the sign over here. It would imply that the voltage is positive here and that the current would be flowing from the negative to the positive over here, and that would imply this direction. And if it's in contradiction with I2, so if that's the case, then the result would be this minus this is like it's putting it's not putting power away, but it's being a drain on the system because it's working against I sub 2. So if that's the case, we would make a slight change over here, and then we will put this sign this way to indicate a drain on the system. But I think this completes basically this bond graph. I'm not going to put the numbers because the numbers on the bonds can be put also by CAMG as well as the causal marks. I just did it so that we can practice, but we don't really have to put those causal marks if we're using the software. We're using CAMG.